let's look at some confidence interval stuff. I got vaccinated for COVID, and many people I know have, and many have not. Like my brother refuses to get vaccinated. That's his choice. That's okay, as long as he stays away from my mother. Now, COVID is an issue. In some places, it's worse than others. Like I was reading about India the other day. Things are really crazy there right now. And Umatilla is starting to spike again, and there's talk about kind of cutting things back again here in restaurants and social gatherings. So that's a concern to me because I live around here. Although I'm vaccinated, I'm worried about the people that aren't. So I was just looking up some data about the vaccinations and how effective they are. And I know many people that got the first vaccine for, say, COVID and Moderna, but didn't get the second. Some people, it was because they thought one was enough. Other people heard friends of theirs felt sicker getting the second shot. And then there's this misconception out there that somehow if you get the vaccine and feel sick after, then you could give somebody COVID, which is totally not true. So there's a lot of misconception out there about why people are not getting the vaccine. But in particular, what I wanted to do is just take a look at a quick bit of data here that they give us. So efficacy is the percent of the population that's vaccinated that that is exposed to the disease but doesn't have any effects from it. They don't notice that they were exposed to it. And the claim is that within 7 days of the second dose of Pfizer, Moderna is pretty similar, that there's a 95% efficacy, and they state, actually it's 94.6, and they state next to that here, this is a different 95% than that one, I'll get to that in a second, but they state a confidence interval here. So I just want to take a look at their confidence interval and what it means. Let's copy that, put it in the notes. So this is the Pfizer vaccine efficacy. Challenging my already challenged spelling, efficacy. Paste that in here, and let's see, I see the chat lighting up. Give me a sec. All right. Yeah, that's a good point about metabolic health. Yeah, and as far as transmission, it's you know, the viral load, right? So if me and my brother and my mother were in the same room and for a long time, more than 15 minutes or so, then, you know, the risk for my mother getting it goes up if he had it. So back to the efficacy here, they had a claim that the efficacy was about 94.6%. And here they have what's called a 95% confidence interval. 95% confidence interval. And we'll get more into what that 95% confidence means. So that is an important thing we'll get to today. For now, I'm just going to ignore that and look at the interval. Often when we make these predictions about populations, one or two things happens. Sometimes they'll just state the point estimate. So that's what we have right here. So this is the point estimate. And then they sometimes give an interval estimate also. They don't often give the margin of error, but sometimes they do. So when you look up data like this, sometimes they'll just state the point estimate and maybe there's a link to get more information. So like with this Pfizer thing, I pretty quickly found the 94.6, and then like 6 or 7 web pages later, I finally found the confidence interval. And nowhere that I noticed, it could have been there and I just didn't see it, that I see the margin of error to go along with that. So you'll see usually one of 3 things when you look up estimates like this. You'll see just the point estimate. Sometimes they'll give the point estimate. So in this case, this is a proportion P, and then maybe comma, they'll state the margin of error next to it. Or sometimes they'll have it in parentheses next to it. In this case, they didn't state the margin of error. They just went out and said, hey, here's the confidence interval right there. So if I just get a straight line, just kind of plot these out to think about what's going on here. They're saying the low end of what they think the efficacy is 89.9%. They think the high end for how effective the second dose is after 7 days or more of getting it, they think it's 97.3%. And then their 94.6 is somewhere in the middle. Now, confidence intervals are not always symmetric. I talked about that a little bit the other day, and that depends on a lot of different things. But for the margin of error, I mentioned in class, the safest way to calculate the margin of error is to just look at the total spread of the interval. What's that distance, and divide by 2, right? And that's my estimate of the margin of error, which we usually consider from the center to the edge. But again, not all confidence intervals are symmetric. So what we're calling the point estimate is sometimes exactly in the middle, but not always. So what we do for the margin of error in situations like that is we just take the total spread, right? So this is what I called the other day my upper boundary. This is my lower boundary. And so we estimate the margin of error, if it's not given, by taking the upper, subtracting the lower, right? That gives me the distance in between, and then cut that in half. So I need to do that for these numbers. Get calculator out. So 97.3 minus 89.9, 2. And my calculator says, when I enter that in, it's 3.7. Again, I took that 97.3 minus 89.9 divided by 2. And since those are percents, the answer is a percent. So this 3.7 is really 3.7%. So that's what I think the margin of error is. So they think the actual efficacy of their vaccine after 2 doses is within 3.7% of 94.6%. So I'm going to write that out. So this is an interpretation of a confidence interval. There's many ways to interpret one. So the actual effectiveness of the Pfizer vaccine is within 3.7% of 94.6%. So that's one way to interpret given the margin of error in the center. And by the within, right, I'm saying I think it's about 94.6%, but the actual real percentage of effectiveness could be as far as 3.7% to the right, or it could be more down there at 3.7% to the left. Could be any number in this interval here. Okay, now I'm 95% confident that that's true. Could I be wrong? Yeah, the actual effectiveness could be below 89.9%. It could actually be above 97.3%. I don't actually know that, but based on the research, we're 95% certain it's in here. No guarantees. Other way we state it, so again, this isn't the most common way, but I just kind of wanted to get into our minds. What does that margin of error mean? The more common way of interpreting a confidence interval is just to state the lower and upper bounds. So instead of saying within, what we'll often write instead, choose a different color, is between, and then we would state the lower upper bounds. So between 89.9% and 97.3%. So when I, talk to this about my mom, like she's not sure if she wants to get her second dose, I'm gonna say, you really should, because I think this is, you'll be much more certain to be safe from having really bad effects of COVID. You'll have somewhere between an 89, a 90% chance and a 97% chance of not having serious side effects if you do happen to get COVID after your second dose. With just the first dose, I think it's more like 80% effective, is my recollection from the research I read. So a couple of things here I was trying to get across. One, we have this idea of a point estimate. So that's what we think was happening with the population. And then we have a margin of error. Usually, instead of stating the point estimate and the margin of error, we just give the spread. We think it's somewhere between here and here. And then the other idea coming up here is this idea of what does it mean to be 95% confident? And that's a little bit slippery. So it's not 90% of all people will fall in this bound. That's definitely not what it means. It's not a 95% chance that we're right that this is the number or it's in this range. It's not that either. What the 95% confidence means is that if we did more studies like this, 95% of them would catch the actual population parameter, and the other 5% would miss it, but we have no idea which is which. So interpretation of 95% confidence, which is a whole different thing than the confidence interval. Interpretation of the confidence level that is, what does it mean to say I'm 95% confident? Confident in what? And it's confident in the process. This is not really a probability. So the kind of the only safe way to interpret the 95% confidence is that 95% of similar studies will lead to confidence intervals that actually contain the population parameter. And that population parameter for us is either a mean or a proportion. There are many other things we could try to predict, like the slope of linear regression, the correlation coefficient. I'm not going to go over those. The book mentions them a little bit, but doesn't do too much with them. That's dealt more in a second course. We're just going to focus on means and proportions. I want to keep it as simple as we can.